Hey guys, it's Michelle and welcome to Michelle's STEM Journey. This week's problem of the week comes from the year 2019 10A problem 17 and it deals with permutations and combinations. I hope you all enjoy this video and let's get started. The problem states, a child builds towers using identically shaped cubes of different colors. How many different towers with a height 8 cubes can the child build with 2 red cubes, 3 blue cubes, and 4 green cubes? 1 cube will be left out. In this problem, we will be using permutation with reputation. And so this is the formula that I have written out right here. N represents the number of total items, while the P, Q, and R, they represent number of items that are repeated. So let's just use the word Mississippi as an example. So in the word, Mississippi has 11 letters in all. So N would be 11. So the numerator would be 11 factorial. And then in the word Mississippi, I appears 4 times. The letter S appears 4 times, and the letter P appears 2 times. So 4, 4, and 2, those are the number of items that are repeated. So the denominator would be 4 factorial times 4 factorial times 2 factorial. And if you don't know what factorial is the product of all positive integers less than or equal to the given positive integer. So for example, 4 factorial. 4 factorial would equal to 4 times 3 times 2 times 1. So just multiplying all the whole numbers from our chosen number down to 1. And now that we know what factorial is and how to use permutations with repetition, let's get started with the problem. Looking back at the problem, it says we have 2 red cubes, 3 blue cubes, and 4 green cubes. So meaning adding them together, we have 9 cubes in all, but the question only asks how many different towers with a height of 8 cubes. So that tells us that we have to exclude 1 cube. In order to get all of the possible cases, we can exclude 1 cube from each color. So now we can divide the problem into 3 cases, each representing 1 cube to be excluded. Case 1. We can let case 1 to be letting the red cube excluded. So this will give us the problem of arranging 1 red cube, 3 blue cubes, and then 4 green cubes. The number of total possible arrangements for excluding 1 red cube would be 8 factorial, because 4 plus 3 plus 1, that would be 8. So N would be 8. And then the P, R, and Q would be 1 factorial times 3 factorial times 4 factorial. But because 1 factorial equals 1, we can just disregard that. So this would just equal to 8 factorial over 3 factorial times 4 factorial. When taking the AMC, you can't use a calculator, but it will be extremely hard and time-consuming to multiply 8 times 7 all the way down to 1 and then divide that by 3 factorial times 4 factorial. So we can cancel some numbers out. So we can write out a factorial, which would be, and then we can also write out 3 factorial and 4 factorial. And now we can just cancel out some numbers that appear both in the numerator and in the denominator. So for example, 2 can cancel out with 2, 3 can cancel out with 3, 4 can cancel out with 4. Then obviously 1, we can cancel all of these out because if you multiply 1 by any number, it would still give you that number. We can cancel out 2 in the denominator with 6, and that would give us a remainder of 3 in the numerator. And then 3 and 3 would cancel out. So now we have canceled out all of the numbers in the denominator. And in the numerator, we are left with 8 times 7 times 5. And this would give us 280. So the number of possible arrangements for excluding 1 red cube would be 280. And now let's move on to case 2, which is excluding 1 blue cube. So this leaves us with the problem of arranging 2 red cubes, 2 blue cubes, and then 4 green cubes. So the number of total possible arrangements would be 8 factorial still, because 2 plus 2 plus 4 equals 8. And then the P, R, and Q would be 2 factorial times 2 factorial times 4 factorial. And then we can use the same method as we did in the previous case and cancel out some of the numbers to make it simpler to solve the problem. Okay, so case 2, this would give us 420 total possible arrangements for excluding the blue cube. Now moving on to the last case. Finally, moving on to case 3, which is excluding 1 green cube. And this would give us a problem of arranging 2 red cubes, 3 blue cubes, and then 3 green cubes. And so the number of total possible arrangements would be 8 factorial over 2 factorial times 3 factorial times 3 factorial. And then after simplifying this, we would get 560. So now we have the number of possible arrangements with a cube of each color being excluded. And so now we can just add all of these arrangements together. So it would be 560 plus 280 plus 420. And this would give us 1,260. So therefore the answer would be 1,260.